Hello, I recently uploaded a tutorial video on how to make a head massager bendable by geometrynodes, and the view count is rapidly increasing. I am grateful for this. Actually, that is not the first head massager video. 6 months ago, I uploaded a showcase video of a head massager, which was implemented by rigging. I also wanted to implement the head massager with geometry nodes that time, but any idea didn't come to mind. However, as you all know, I eventually succeeded in coming up with it. I think geometry nodes are great, but there is also a lot to learn from rigging methods. First, I will show you rigging tutorial, and then, in the later part of the video, I'll compare the rigging version and geonodes version. Let's get the tutorial started. First, I will explain the core idea. This rigging method is using inverse kinematics to bend the leg, according to the movement of the IK bone of the leg. It is important to clear the parent relationship of the IK target bone. I recommend you to search commands by pressing F3 key. By setting up bone groups and applying colors to each of them, this not only makes it visually convenient, but also makes it easier to select or deselect the bones within the respective groups. The reason for creating the indicator bone is to determine whether the leg should be bending. I will cover the details later. It is important to apply a shrink wrap constraint to the IK target bone. By doing this, it sticks to the surface of the target object. And needless to say, it should not always stick to the surface. The influence of the shrink wrap should be determined based on the distance between the target object and the indicator bone. This is why I made the indicator. Roughly speaking, when it is far away, the influence should be set to 0, and when it is close enough to bend, it should be set to 1. For this behavior, a mathematical specification is needed, and Driver in Blender makes it possible. Let's use the distance between the indicator bone and the target object as an variable for this driver. In the driver editor's graph, we can consider the x-axis as the expression we defined, and the y-axis as the value applied to the actual influence. Since it's not practical to modify the driver every time the target size changed, it is reasonable to apply the target's scale to the expression in the driver. There is something to be cautious about when using this. Firstly, this driver logic can only be applied to targets with a spherical surface. Secondly, it is important not to apply the target's scale to reset it to 1. If you want to experience it firsthand, try increasing the target's scale and then apply scale with Ctrl A. You will understand what it means. Because I want this to get 12 legs, we need to duplicate and simultaneously rotate 30 degrees along z-axis. As you can see, the driver doesn't seem to be copied. We need to copy and paste the driver to each leg. I tried using the Skinify rig add-on, but it doesn't work as expected. The result mesh is twisted. This could be because I might not have set it up correctly before using the add-on. Instead of using Skinify add-on, I'm going to use some modifiers to make mesh. The techniques now I'm going to show you, I learned it through Joey Carlino's tutorial. If you are interested in this, check the link below. Wow, we made it! Through this process, as you might have also felt, it is evident that it is more cumbersome compared to the geometrynodes version. Yeah, it's time to compare these two types of head massagers. First, is it possible to set multiple targets? In the case of rigging version head massager, it's not possible. Even changing from one to another target is very cumbersome as shown in this video. On the other hand, in the case of geonodes version, it is possible to set multiple targets, simply by adding new target objects into a collection. The collection info node is so powerful. Second, let's observe behaviors on planar surfaces. In the rigging version, at least legs seem to bend naturally, but when it moves away from the center, shrink-wrap logic would be broken. This is simply because it is not a spherical surface. The geonodes version does not show bending. This is because the rotation axis becomes a zero vector, as a result of the cross product that you can find in my geonodes. In both cases, the behaviors are far from the real world. Finally, is it easy to change the parameters? This is overwhelmingly a victory for geometrynodes version. The easiness to change parameters like thickness, the number of legs, and targets, this is the reason why I didn't give up and constantly tried to come up with the idea for geonodes. To sum up, geometrynodes win. Thank you for watching. If you like my Blender tutorial, please like this video, subscribe my channel, and turn on notifications. I'll see you guys very soon. Later.